we go. So Ascend is a data pipeline tool. So what we want to do is to enable developers, data scientists, data engineers, data analysts to quickly and easily and intelligently build data pipelines. We sit on top of Snowflake, so what we make it really easy to leverage all of the awesome computing power in Snowflake, as well as the storage, compression and efficient storage in Snowflake as well. So what we're looking at here is a very simple data flow in Ascend. And data flows in Ascend, just like most things, flow from left to right when we're looking at the visual. So the first step of a data pipeline is typically ingesting data from siloed sources and centralizing that into your Snowflake warehouse. So that's what we represent with these teal boxes. We call those read connectors. And so in this case, we're pulling from an Amazon S3 bucket. And if you are curious about the different places that Ascend can pull data from, we can take a quick look at the different flavors of where we can sync from, whether it's file storage and blob stores, other warehouses, maybe you're pulling from another Snowflake warehouse or a Hive warehouse, a whole bunch of different databases, on-prem or cloud hosted, event streamings, different file storage systems, and we're building out a whole bunch of different connectors here for any API-based sources through our partnership with CData. And then last, but definitely not least, is custom Python connections, where you can write your own custom Python code to connect to effectively any source and bring it into Snowflake. So in this case, we're just pulling from S3 some raw sensor data. This is going to be a weather example. And what we can do here is take a quick look at some of a sample of the records where we have a single date, the amount of precipitation that was recorded at a station, a weather station. And in each component in Ascend, you can quickly and easily look at the schema. The next step here in the middle are these red boxes. This is where we really believe that most users in Ascend get the most value and benefit. Data engineers, data scientists, what they primarily want to do is take raw data and apply business logic to make it useful for your business. So in this case, what we're doing here in a couple of simple steps is executing some SQL code against that raw sensor data. What we're doing is saying that if there's over 0.5 inches of rain, then we're going to classify that as a rainy day. If not, it's not a rainy day, and we added a new column called weather. And we're referencing that raw sensor data that was generated in the step prior. The next step downstream from here is we are going to do some simple inner joins of the data. We can take a look at it here to get a full look at the code, to find the max sensor reading per day. So where did we, on any given day, actually find the highest amount of precipitation? Now, in this case, we're executing Snowflake SQL, as you can see here. What Ascend also enables you to do is effectively run any code that you need to against your data, wherever that data lives. So we love Snowflake's computing power. It's really awesome and easy to run Snowflake SQL. We also think that Snowpark Python is very, very efficient and useful. So it's really easy to spin up and execute a Snowpark Python job within Ascend, within your pipeline. So you can easily jump between SQL, Python, or running Snowflake merge queries. The other option that Ascend provides as well below here is Spark computing. So if you need to access data outside of your Snowflake warehouse, what Ascend manages under the hood is a Spark cluster for you. So you can execute your Spark Python or Spark SQL easily within this pipeline. The next step after you've defined your business logic, you've got the output data that you want, is delivery of data. So that's what we show here on the right. And there's two concepts here. One is a data feed. A data feed is an object that lives within Ascend, which makes it really easy for folks to pick up and subscribe to data in other data flows. So in this case, we're publishing a data feed that's called max sensor reading by day. And what other folks can do, or if you want to build another pipeline using this data, you can easily subscribe to this data feed and then start building your own transformations from there. What's nice about that is as this data continually gets updated, that you can also ensure that your downstream pipelines also are using the freshest and most accurate data. So this is a concept of other data feeds within Ascend. And then the other notion here is delivering data to an external source. So in this model, we want to have an example of our analytics production Snowflake environment. So what we're going to do is deliver to a schema in Snowflake that is called analytics prod. And at the end of the day here, what we're doing, and I'll show you guys in Snowflake, we're actually spitting out the final weather data that your analytics team is using to feed into your BI tool of choice, where you can do all of your visualizations with this cleaned weather data. Now let's walk through an example here where your analytics team feeds you a request saying, this is great, but there is this station identifier that is not very useful for us. We don't know whether that is Orlando, Florida, or Chicago, Illinois, or San Francisco. So we need to know where this station identifier represents in terms of location. Now, if you think about what you normally would do in terms of as a data engineer or anyone managing this pipeline, what you typically need to do is probably jump through a myriad of different tools and places and execute different code to ingest that new data source into Snowflake, make sure that the schema, it looks correct. You need to join these two data sets together, bring in that station name field, and make sure that it then propagates to each step in this pipeline. You probably need to run some tests against the schema during each stage, and then you likely need to refresh the whole pipeline and cross your fingers that it runs successfully. What I'll do here is I'll show you a couple things that you can easily do in Ascend. So what we'll do is create a new read connector. What I know is that we have some station weather station information in this Postgres database. So I'm going to go ahead and use this connection that we've already established. I'll jump into the public schema, and right here is this NOAA stations table that we want to bring over into Snowflake. So I'm going to name this object in Ascend weather stations, and I can come down here and hit generate schema. What Ascend does for you automatically is looks at that source, identifies the columns and data types within that table, gives you a preview of the data. We can take a look at this and say, okay, this looks right. Let's bring this into Snowflake because I want this station name field right here. A couple other things to call out is that you can define how frequently you want this to run. If we know that weather stations there's frequently new weather stations getting added, we could have this run once a day, once a week, or even hourly or on a minute cadence. I'll go ahead and create this object. And so immediately you can see here in the DAG, we've got a new component, which is a read connector, which is connecting that Postgres database and bringing that data into Snowflake. So the next step that we would logically do is we have this weather station data and we've got the raw sensor data. We need to bring it together. So I'm going to create a new transformation from here. What I'll do is paste in here some simple SQL code. It's joining that raw sensor data to that new weather stations data. We're doing a little bit of data munging on the ID format so it matches. And we're bringing in all of the data from the raw sensor ingestion. And then we're also bringing in the station name as well as latitude and longitude if we want to do some cool visualizations with maps. So I'll create this object. By now you can see that we've already synced 120,000 records from Postgres into Snowflake. And this job is automatically running the join between those two data sets. So now we have an output data set. We can take a look at the schema. It's all of the precipitation information, the date information, the station, and then the new data that we just brought in, station name, station latitude, station longitude. We can take a look at the records as well. What the next step we would want to do here is I'm going to come into define rainy day where we start defining our business logic. And this is where Ascend makes it super easy for developers to build, maintain, update pipelines. I no longer want to reference that raw sensor data. What I want to do is point to this weather stations transform data set, this new data set. And so I'm going to point to that and pull in everything from there. And so I'm going to hit update, and you'll notice a few things happen. One, Ascend automatically updates the DAG for you, so you can easily understand the data flow, two sources getting joined together, and then our logic is flowing from there. And then the next really important piece here is that Ascend recognizes that these downstream components are out of date. We need to add those station name and latitude and longitude columns to each of these components downstream without you needing to do anything manually. So we automatically recognize that and propagate that change down through to all of these different components. And now your data feed has all of the information that you want available for you there. Let's say another example of a change request comes in from your analytics team and they say, you know what, we've done some new analysis and actually 0.5 inches of rain is no longer the threshold for a rainy day. It's actually now down to 0.45. So if I come into this SQL logic and I change this to 0.45, what you'll see is the same thing. Now the schema hasn't changed, but the output data from defining a rainy day has changed. So Ascend will automatically rerun this step and all downstream steps. So you now have the freshest and most accurate output data based on the business logic that's defined here. So I'll give this a couple seconds to run. And the beauty of this is that, like I said, other data flows that might be using this data feed now have the updated logic as well with 0.45 inches of rain, that new threshold, and those additional columns in the schema if they choose to use station name. And then your analytics team, really quickly, what we saw before where we saw station IDs represented here without any information about latitude or longitude. If we run this again now, here you go. You've got station name as requested, as well as your latitude and longitude, in addition to the weather data that is on the new 0.45 threshold. So that's it for this demo. Really simple example of how easy it is to build new pipelines, bring in new data sources, edit existing pipelines, update the business logic, and make it really easy to deliver that production data to whatever source is consuming it.